Hi, so today's topic is lambda expression. So, without wasting any time, let's get into it. Okay, so first thing first, what is lambda expression? A lambda expression is an anonymous function that has no name, no return type, no access modifier, and can be passed as data or a behavior. Its general syntax is like this: if we have multiple statements, then we have to pass it inside the parenthesis. This arrow is called the lambda operator. Now, why was lambda introduced? Before Java 8, passing behavior was very verbose, as we discussed it in our previous video also, that if we have to pass the function to a method, we have to create an anonymous class of it. So if we have to declare the anonymous class, and we have to write all this code, and all this code is very verbose. With lambda we can just simply write it like this, which is much shorter and easier to read. Now, how does lambda work? Consider a functional interface that has an abstract method. We can implement it using lambda like this. What does the compiler understand? Int that a and b are int, return type is int. This lambda implements calculate. Okay, lambda doesn't exist on its own, it must target a functional interface. So basically lambda and functional interface go hand in hand. Functional interface can be implemented using lambdas. So what are its syntax variations? First is no parameter. If we are not passing any parameter, we have to keep the parenthesis as empty. If we are passing one parameter, then the parentheses are need not to be necessary. These both things are equivalent. If there are multiple parameters, then parentheses are mandatory. If there is a single statement, then curly braces are not mandatory. If there are multiple statements, then curly braces are required. Okay, next is type interference. Java compiler interfere parameter types. So if in method declaration it is like int a comma int p, then in our lambda we need not to mention int a comma int p. Lambda itself knows that it is of type int because it knows method signature from the functional interface. Now coming to the very important topic of this video, that is variable capture. What does it mean? A lambda can access variable from the enclosing scope. So showing you with an example. Suppose we have a number and here we are just printing this number. So this will work fine. But what if I want to perform some operation and I just change this number value? We are getting a compilation error now here. What does it say? Variable used in lambda expression should be final or effectively final. What does it mean? So we all know there are two types of memory in Java. One is stack memory and one is heap memory. In stack memory, all the methods get stacked and all its related variables and everything. And in heap memory, all the objects are present. So when this function executes, this main method will be inside stack memory, and this object will be inside the heap memory. Now there can be some scenario when the stack memory gets cleared and the object is still present in the heap memory, and that object is using the stack memory variable. So in this case, if the if the object is using the reference, it can cause issue, or if it using the direct variable itself, it can cause issue. So what actually my lambda does is it uses the copy of the variable to avoid this. Now if we are changing the variable later on, this breaks the rule. This causes the ambiguity, like you have changed the variable from 10 to 20 but you're still getting 10. Why? So to keep its rule intact, Java has declared one thing, that the variable that are used inside the lambdas should be final or effectively final. Now, what does effectively final means? You don't have to write explicitly final, but if you don't modify the variable after the initialization, then Java automatically treat it as effectively final. Okay, so this will work, but this will not work because we are changing. It will give compilation error. Similarly, this will work and this will give compilation error. Now, why this restriction? I just explained. So local variables live on the stack while lambdas outlive the method that created them. The lambda capture the value of the local variable, not the variable itself. Okay, so it keeps a copy of the local variable. Requiring it to be final avoids inconsistent behavior and simplifies implementation. Okay, so coming to our next topic, next is lambda versus anonymous inner class. So before lambdas, this is how you used to declare the anonymous class, and after lambda we use this. So here both these are completely different. So here this will refer to this runnable, but here inside lambda this will refer to the class in which it is present. Okay, this is a favorite interviewer question. Can lambdas access instance variables? Yeah, it can. Okay, because it is not present inside the stack memory. No issues. We can increase it also, no issues. Static variables, yes, it can. Okay, now next thing is, can lambdas throw exception? So see, runnable and callable. So I'll show you. If we go inside this runnable, its abstract method declaration does not add any throws exception definition. Okay, now if we go to callable object, this declaration throws exception. So if the method declaration has throws, we can throw an exception, but if it doesn't, we cannot. Checked exception depend on the abstract method throws clause. Okay, here this callable.call doesn't declare IO exception directly. Actually, callable.call declares throws exception, so IO exception is allowed. By contrast, runnable.run declares no checked exception. So throwing IO exceptions from runnable lambda would cause a compilation error. Okay, next is functional programming style. So traditionally, if we used to sort anything, we used to pass a comparator ka anonymous inner class like this, but with lambdas we can use it like this. So I will create a separate video on all these implementations. Okay, then I will explain thoroughly. We can also use method reference. That will be our next topic. Lambda execution is lazy. A lambda expression itself is just a piece of behavior. It doesn't execute when it's created. Now what does it mean? We have created this lambda. If we execute this program right now, it won't do anything. Nothing prints yet. It will print only when we call the function. Okay, now this laziness is in the broader sense, like stream operations. Okay, I will make a video on streams also. In there the laziness is completely different, that comes from the API. Here the laziness that we are referring to is completely different. You get it, right? Like when we call the object, then only it gets executed. Next is, how is lambda expressions implemented internally? Many candidates say that Java creates an anonymous inner class, and that was actually made true before Java 8. But what actually happens is compiler generates an invoke dynamic instruction. JVM uses Lambda Meta Factory. An implementation of the functional interface is created at runtime. Okay, we discussed this in previous video also. What are the benefits of Lambda? Better performance, less class file generation, lower memory overhead, JVM optimization opportunities. Okay, some theory questions that can come up in the interview. Now, what are some common built-in example? Runnable predicate that takes in a variable and outputs only a boolean, function that takes in a generic and returns different generic, consumer that takes in something returns nothing, supplier that takes in nothing but returns something. We discussed all this in previous video also. Now, frequently asked interview questions. Can Lambda exist without a functional interface? No. Lambda cannot exist without functional interface. Okay, functional interface can exist without Lambda, but Lambda does not mean anything if you are not passing a functional interface into it. Can we overload methods using different functional interface? Sometimes, but be careful. So see, there are these two methods which have different parameters. One is taking a function and another is taking a consumer. So if we are passing here, we are passing a consumer, this will work. But if you will make it ambiguous for the program, that will not work. Can lambdas have constructor? No. A lambda is not a class. Can lambdas extend a class? No. It implements a functional interface. Why can't we modify local variables inside lambda? We just discussed this. Okay, because local variables are captured by value and must remain final or effectively final for correctness and thread safety. Is lambda an object? Yeah, it is an object. At runtime, evaluating a lambda produces an object that implements the target functional interface. Now, here are some senior level interview questions that you can just go through and check whether you are able to answer after going through this video. I will create a separate video for this, and there are some implementation questions also that we will solve in next video. So yeah, that's it for this video. Thanks. Bye bye.